Hello and welcome to another GCSE Maths Higher walkthrough, and this is the third and last paper in the series, which is a calculator paper. And as always, when we're going through these questions, it's a good idea to pause the video and have a go at the questions yourself, and then if you do get them wrong, you can have a look at my work solutions. Okay, so question 1. The scatter diagram shows information about 10 students. For each student, it shows the number of hours spent revising and the mark the student achieved in the Spanish test. So it looks like the more hours people spend revising, the better they do on their exams, which makes sense. And this is a nice little reminder to all of you back home to get revising. Okay, one of the points is an outlier. Write down the coordinates of the outlier. So an outlier just means one of them does not follow the general trend of the rest of the data. And we can see that that's this one here. Now the coordinates, so we go along 4 and we go up 10. So our coordinates are 4, 10. Okay, now it says for all the other points, draw the line of best fit. So a line of best fit is a straight line that goes through all of our points. And you want to try and get your line so that there are an equal number of points either side of the line. So if I just get my line tool out, and obviously you would be using a ruler for this and a pencil. So just adjust it slightly and use a pencil so that you can rub it out and try again. So that looks about right. Okay, and let's select that. Now describe the correlation. Now correlation is just another word for relationship. So describe the relationship where it is a positive correlation. That's all we need to say. We just need to say that is a positive correlation. Right, now it says a different student studied for 9 hours. Estimate the mark gained by this student. So we obviously don't know what mark they scored, but using our data we can estimate the mark. So they studied for 9 hours, which is here. So if we go up to our line of best fit, so if we draw a line up to our line of best fit and then go along to our y-axis, we can estimate what score they got. It looks like it's halfway between 60 and 70, so I'm going to say 65. They've got a score of 65, and there will be some margin for error on this. Now it says the Spanish test was marked out of 100, and Lucia says, I can see from the graph that had I revised for 18 hours, I would have got full marks. Comment on what Lucia says. Well, the most important point here is that this is only an estimate. So this line of best fit that I've drawn in is only an estimate to predict approximately what mark someone would get. And if we used the line of best fit properly and we went up from 18, so if we went up from 18 to our line, we can see that it would touch the line approximately up here, which is greater than 100, which is impossible. You cannot get a mark greater than 100 if it is out of 100. Okay, let's go on to question 2. Okay, the length L of a line is measured as 13 centimeters correct to the nearest centimeter. Complete the following statement to show the range of possible values of L. So our length is 13 centimeters, and that is being rounded to the nearest centimeter. So the smallest possible value that could be would be 12.5 centimeters, because if we're rounding this to the nearest centimeter, it's going to be rounded up to 13. Anything lower than this, it will be rounded down to 12. And then so that's the lower bound. The upper bound will be 13.5 centimeters. Now just be really careful. If the length is exactly 13.5, it would be rounded up to 14. But if we have a look at this inequality symbol here, this says less than 13.5. So anything less than 13.5 will also be rounded down to 13. Question 3. Line L is drawn on the grid below. Find the equation for the straight line L and give your answer in the form y equals mx plus c. Well, this is our standard equation for a straight line where the m stands for the gradient and the c is the y-intercept. So first of all, let's calculate the gradient of our line. So we know the gradient is the change in y over the change in x. So it's the slope, how steep is our line. So if we pick 2 points on our line, these 2 points here, the gradient, the change in y, we're going from 1 to 3. So we're going up by, sorry, not up by 3, up by 2. We're going from 1 to 3. And the change in x, we're going from 0 to 1, which is 1. So we're going, for every 1 we go along, we go up 2, so that is a gradient of 2. So that's our gradient. Our y-intercept, sorry about that, that's my phone going off. Our y-intercept, well, is 1. So our y-intercept is 1 and our gradient is 2. So the equation of our line is y equals 2x plus 1. Question 4. Jenny works in a shop that sells belts. The table shows information about the waist sizes of 50 customers who bought belts from the shop in May. Calculate an estimate for the mean waist size. Well, when we're calculating an estimate, the first thing to do is to find the midpoint of our intervals. So let's just write down here MP for midpoint. So the midpoint of the small belt size is going to be 30. The next one is going to be 34. Then it's going to be 38. And then it's going to be 42. And now we've got the midpoint, we need to multiply that by our frequencies. So it's going to be frequency times our midpoint. And luckily for us, we do have a calculator handy. So some of these I can do without a calculator, but we'll use it anyway. So 24 times 30, 24 times 30, that gives us 720. 34 times 12 is 408. 38 times 8 is 304. And finally, 42 times 6 is 252. So all of these, when we add them all together, that is just the total number of inches. And then we're going to divide that by the total number of people. So let's add all of these together. 720 plus 408 plus 304 plus 252. That gives us 1,684. So that is the number of inches, or the waist size, the number of inches for the waist size. And now to calculate the mean, an estimate for the mean, we do the total number of inches, 1,684, divided by the total number of people, number of customers, and we know that that is 50. And if it wasn't told, if it wasn't given to us explicitly in the question, well, we would just add up these frequencies. So 24 plus 12 is 36, 36 plus 8 is 44, 44 plus 6 is 50. So there's 50 people. So divide that by 50 and we get an answer of 33.68 inches. 33.68 inches. Now we can just dummy check our answer. So the waist sizes go from 28, which is the minimum, up to 44, which is the maximum. So we know that our mean has to lie between these two values, and it is somewhere in the middle there. So I'm pretty confident that we've got the right answer. It's 33.68. Okay, belts are made in sizes small, medium, large, and extra large, which we can see here. Jenny needs to order more belts in June. The modal size of belts sold is small, which we can also see here because there's 24 of them. Jenny is going to order 3/4 of the belts in size small. The manager of the shop tells Jenny she should not order so many small belts. Who is correct, Jenny or the manager? You must give a reason for your answer. So Jenny says Jenny's going to order 3/4, and the manager says she shouldn't order so many. So is 3/4 too much? Or too many, I should say. 3/4 too many belts, small belts to order. Well, let's look how many belts she sold that were small. So she sold 24. So let's do it over here. She sold 24 out of a total of 50. Now 24 over 50 is definitely not 3/4. So we know that 25 over 50 is a half. So she's just sold slightly less than a half. Okay, now let's go on to question 5. Question number 5. The diagram shows a wall in the shape of a trapezium. Karen is going to cover this part of the wall with tiles. Each tile is rectangular, 15 centimeters by 7.5 centimeters. Tiles are sold in packs, and there are 9 tiles in each pack. Karen divides the area of this wall by the area of a tile to work out an estimate for the number of tiles she needs to buy. Use Karen's method to work out the estimate for the number of packs of tiles she needs to buy. So, first of all, let's work out the area of the wall that she needs to cover. So how do we work out the area of a trapezium? Well, we need to add the parallel sides together, first of all. So we do 1.8 plus 2.7. And we half that, divide it by 2, and multiply it by the height of our wall, which is 0.8. And when we put all of this into our calculator, we get 1.8 meters squared. And now we need to work out how many tiles she needs to cover the wall. So each tile is rectangular, 15 centimeters by 7.5 centimeters. Now our area for the wall is in meters squared. So let's convert these into meters first. So each tile is going to be 0.15 centimeters, or 0.15 meters I should say, sorry, multiplied by 0.075 meters. Because I've just converted each of these into meters, I've divided both numbers by 100. So we've got 0.15 times 0.075, which gives us 0.01125 meters squared. So this is what each tile is. And if our wall is 1.8 meters squared, to work out the number of tiles, let's just write down number of tiles. Well, we're just going to divide 1.8. So we're going to do 1.8 divided by 0.01125. So 1.8 divided by previous answer. That gives us exactly, which is nice, 160. So we need 160 tiles in total. Now, that's the number of tiles, but we need to work out an estimate for the number of packs of tiles. So there's 9 tiles in each pack. So we're just going to do 160 divided by 9. So we can divide that by 9, and that gives us 17.7 recurring packs. Now, obviously, you cannot buy 17.7 recurring packs. So just to be on the safe side, why don't we buy 18 packs? I'm just going to round this up to 18. So my answer is going to be 18 packs. Now it says Karen is advised to buy 10% more tiles than she estimated. Buying 10% more tiles will affect the number of tiles Karen needs to buy. I think that's supposed to say affects the number of packs. That's a small mistake on the question there. The number of packs that Karen needs to buy. She assumes she will need to buy 10% more packs of tiles. Is Karen's assumption correct? You must show you're working. So she's advised to buy 10% more tiles than she estimated. Well, she estimated 160 tiles. So to work out sort of 10% extra from 160, we can just do 160 times 1.1. So, oh well, I know that 10% is 16, so add 16 onto 160, that gives us 176. So 176 tiles. Now, does that affect the number of packs that Karen needs to buy? Well, there's still 9 tiles in each pack. So now if we do 176 divided by 9, that will tell us how many packs that she needs to buy. So 176 divided by 9, which gives us 19.5 recurring. 19.5 recurring, which obviously again we can't buy 19.5 recurring packs, so we'd have to round that up to 20 packs. So let's round that up to 20 packs. So if she didn't get the 10% extra, she would have got 18 packs, but if she did, she would have got 20 packs. Now, is this 10% more? So is 20 10% more than 18? So we can say that the increase in the number of packs is 2, and that is more than 10% of what we originally found, because 10% of 18 is 1.8. So to answer the question, is Karen's assumption correct? We would have to say no, and you must show all of your working. Well, this is completely acceptable. This is all of our working that we've shown. And that was quite a tricky question there. So let's go on to question 6. Question 6, factorise x squared plus 3x minus 4. Well, to factorise these sort of expressions, we're going to first of all look to see whether there are two numbers that multiply together to get negative 4 and add together to get positive 3. And it looks like there are two numbers, so the numbers that I'm thinking of will be, well, one of them has to be negative and one of them has to be positive to get a negative answer. So the numbers I'm thinking of are -1 and +4. Let's just make sure we've got that correct. So -1 times 4 is -4, and -1 plus 4 is +3. So how would you factorise this? We would just put in two separate brackets. So if we just put two brackets here, we'd put x minus 1 and x plus 4. Like that. Okay, question 7. Here are the... Oh, and just before I carry on, you can always check your answer by expanding these brackets. So if you expand these brackets, you should get back to the original expression. Okay, question 7. Here are the equations of 4 straight lines. 2 of these lines are parallel. Write down the 2 parallel lines. Well, for 2 lines to be parallel, they have to have the same gradient. So let's just work out what the gradient is on each of these, and then hopefully 2 of them are the same. So for A, the gradient is 2. That's quite easy. It's just the number in front of our x. Now for B, we've got 2y equals x plus 4. 2y equals x plus 4. And to calculate the gradient, our equation must be in the form y equals mx plus c. We've got 2y, so we need to divide everything by 2. So this is going to be y equals a half x plus 2. So our gradient is a half. So for B, our gradient is a half. So those two are definitely not parallel. The next one, 2x plus 2y equals 4. Let's write this down here. 2x plus 2y equals 4. So we need to get it in this form up here. So first of all, if we subtract 2x from both sides, we're left with 2y equals negative 2x plus 4. And now if we get y on its own, so if we divide everything by 2, we've got y equals negative 1x, or just negative x, plus 2. So what is our gradient? Well, our gradient is negative 1. So the gradient for C is negative 1. So D is going to have to match up with one of these. So for D, we've got 2x minus y equals 4. So if we get y positive, let's put y on the right hand side. So if we add y to both sides, it's going to be 2x equals 4 plus y. And if we subtract 4 from both sides, we're left with 2x minus 4 equals y. So our gradient is 2. So for D, our gradient is 2. So we can see that the 2 gradients that are the same are A and D. So those are our 2 parallel lines, A and D. Question 8. Ian invested an amount of money at 3% per annum compound interest. At the end of 2 years, the value of the investment was £2,652.25. Work out the amount of money Ian invested. So let's say that the amount of money that Ian invested was just A. Let's just call that A. And he invested that money for 2 years at 3% per annum compound interest. So our multiplier, we're going to multiply that by 1.03. That would be if he got 3% interest over 1 year. But it's at the end of 2 years, so we're going to raise that to the power of 2. Or we could think about it as 1 times 1.03 times another 1.03. And our answer is £2,652.25. So that's the total amount of money he's got in his account after 2 years. Now at the moment, we are multiplying by 1.03 squared. So to get A on its own, if we divide by 1.03 squared, obviously we'll divide both sides by 1.03 squared. What are we left with? Well, we're left with A equals, let's just get the calculator out, £2,652.25 divided by 1.03 squared. That gives us a nice round number, £2,500. 2,500. That is our answer. And again, we can check this. So we can check this by doing 2,500 multiplied by 1.03, because that's how much interest we're getting, 3% interest, over 2 years. And when we put this into a calculator, you will find out that you do get £2,652.25. Okay, Noah has an amount of money to invest for 5 years, and he's got 2 possible options. Noah wants to get the most interest possible. Which account is best? you must show how you got your answer. So he can either invest in the saver account where he gets 4% per annum, or he can invest in the investment account where he gets 21% interest paid at the end of 5 years. So this is 4% compound interest each year, and this is just 21% interest at the end of 5 years. So let's first of all start with the saver account. So the saver account, let's write this down, saver account gets 4% interest, 4% per annum compound interest. So our multiplier is going to be 1.04, and that is over 5 years. So that is over 5 years. So if we just work that out, 1.04 to the power of 5, that's going to be 1.216. I'm just going to round 1.2167. And if we convert this into an overall percentage increase, well, that's going to be 21.67%. Now let's look at investment account. Well, and you can probably already see this. Investment account, we're already told what the interest paid at the end of 5 years is 21%. So we can clearly see that saver is the better option. So let's write this down. Saver is the better option. Question 9. The diagram shows two vertical posts, AB and CD, on a horizontal ground. AB is 1.7 meters, and the ratio of CD to AB is 1.5 to 1. The angle of elevation of C from A, so we could draw this in. So let me just get my line tool out. So if we draw a horizontal line, and obviously this isn't perfectly to scale, but hopefully you get the idea. So this is a horizontal line which is parallel with the ground. The angle of elevation of C from A, so now if we draw another line in, so this angle here, so the angle of elevation of C from A, so we're going from A to C, is 52 degrees. So let's just label that. So this angle here is 52 degrees, and you can clearly see this isn't to scale because this is much smaller than 52 degrees. Calculate the length of BD. So we need to calculate this length here. Give your answer correct to 3 significant figures. So we know what the ratio is of this length to this length. So it's 1.5 to 1. So CD is 1.5 times bigger than AB. So we just need to multiply 1.7 by 1.5, which gives us 2.55. So CD, this whole length here, is 2.55. Now we can calculate what this missing length here, this leg of our triangle, by just subtracting. So we can do 2.55 subtract 1.7, and that gives us 0.85. 0.85. Now we've got this length and we know this angle, so now using trigonometry we can calculate dB. We can calculate D or BD, whichever one you want to call it. We can calculate this length using trigonometry. And I always like to write SOHCAHTOA to help me. SOHCAHTOA. So which trig function are we going to use? Well, if this is our angle, this is the opposite side length and this is the adjacent side length. So the one that uses the opposite and the adjacent is TOA, or tan. So let's write this down. So the tan of our angle, which is 52 degrees, is equal to the opposite, 0.85, divided by the adjacent, which we don't know. That's what we're trying to work out, which is BD. So just to rearrange this equation, BD is going to be BD is equal to 0.85 divided by the tan of 52 degrees, which we just need to put into our calculator. So 0.85 divided by tan 52, and that gives us 0.66409. We'll just leave it like that because then we do need to round our answer. So give your answer correct to 3 significant figures. So it's going to be 0.664. 0.664 meters. And you might be thinking that seems too long, because if this is 1.7, how can that be 0.664? But you just got to remember that this angle is clearly not to scale. Question 10. On the grid, shade the region that satisfies all these inequalities and label the region R. Now, the way I like to do this is just to focus on one of them first and just treat it like an equation. So let's draw the line x plus y equals 4. So x plus y equals 4. What would that look like? Well, just to make things a bit easier, we can rearrange this to put it in y equals mx plus c form. So if we subtract x from both sides, it's going to be y equals negative x plus 4. So our y-intercept is 4 and our gradient is negative 1. So for every 1 we go along, we go down 1. So along 1, down 1, along 1, down 1, along 1, down 1, along 1, down 1, along 1, down 1. So we can put another point there. And if we just get our line tool out, so we can draw that line in. And just be careful. So when we draw the line in, you need to think about, is it going to be a solid line or is it going to be a dashed line? And it all depends on what the inequality symbol looks like. Now this is saying that x plus y is less than 4. So because it's less than and it's not equal to, we draw a dashed line, not a solid line. So I don't think my pen tool is, or my line tool is able to do that, so I'll just do it freehand. So our line, if you forgive me on how messy this is going to look something like this. Just keep going. It's just a dashed line that goes in this direction. Okay, now let's focus on the next one here. So y is greater than x minus 1. And again, if we just treat it like a normal a line, it's going to be y equals x minus 1. And now let's draw this line in. So the gradient is 1 and the y-intercept is negative 1. So it goes through the y-axis here and it has a gradient of 1. So for every 1 we go along, we go up 1, along 1, 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 up 1. So there, and I can use my line tool. No, I can't. Just noticed again how it's greater than, it is not equal to. So we have to draw a dashed line again. So let's draw another dashed line. Something like this. That's pretty accurate. And now finally let's do our last one. So y is less than 3x. So again, let's just write that as an equation. Y equals 3x. So what would that line look like? Well, it would go through the y-axis at 0 and it has a gradient of 3. So for every 1 we go along, we go up 3. So along 1, up 3. Along 1, up 3. And we can go the other direction as well. Along 1, down 3. And again, this one is not equal to, so again it's a dashed line. So they're all going to be dashed lines. They're all going to be dashed lines. So let's just keep going like that. Now, if we have a look at the inequalities, the symbols, we know which region we're going to shade. So the first one, it was less than, so it's going to be underneath the line. It's going to be underneath the line. The red one was greater than, so it's going to be above the red line. It's going to be above the red line. And the last one is less than the purple line. So it's going to be underneath the purple line. And the region that satisfies all three of these inequalities is this triangle in the middle here. So it does say label it R. So let's do that. So let's get a slightly thicker pen just to make it stand out. Let's do that in orange. So I'm going to circle it as well. So our region R is this region here. Question 11. Write x squared plus 2x minus 8 in the form x plus m in brackets all of that squared plus n, where m and n are integers. Now, as soon as I can see this, this is a completing the square question. So we need to complete the square on this quadratic expression. So let's just write it down again. It's x. Oh, let's just change the from the last question. I was on a thicker font. So let's just have another go at that. So let's see if this works. So x, yes, we're back to normal. X squared plus 2x minus 8. Now to complete the square, what we have to do is we have to half the coefficient in front of the x. So half this number and then square it and then add that on. So if we half 2, that gives us 1. 1 squared is still 1. So we have to add on 1 to this expression so that we can complete the square. So let's do that. So x squared plus 2x. And now I'm going to leave a space and then minus 8. And that space is so that I can put in that number 1. Okay, so remember, half of 2 is 1, 1 squared is 1, so I need to add on 1 to allow me to complete the square. But this is really important. We can't just add on 1, we have to subtract 1 as well. Otherwise, I've changed the expression. Now, these two expressions are exactly the same. Because if I'm adding 1 and then subtracting 1, I'm not changing the value of my expression. So these two things are exactly the same. And now, if I just focus on this part that I've put in brackets, I can factorize this. So two things that multiply together to get 1 and add together to get 2, well, they are 1 and 1. So this just factors to x plus 1 times x plus 1, or I could say x plus 1 squared. And then we've got minus 8 minus 1. That gives us minus 9. So let's just check our answer. Have we written it in this form? Yes, we have. Because m equals 1. We don't need to write this, but it just probably helps you understand that m equals 1. And the n at the end is this number here, which is negative 9. Question 12. The diagram shows a cuboid, and we're given the lengths of the cuboid, so we can just write those in. That's probably helpful. So AB is 7 centimeters, AF is 5 centimeters, and FC, this sort of diagonal from the top left of our cuboid to the bottom right of our cuboid, is 15 centimeters. Calculate the volume of the cuboid. Give your answer correct to 3 significant figures. So first of all, let's calculate what this diagonal is here. So this diagonal here. And to do that, we're just going to do 5 squared plus 7 squared. And then we're going to take the square root. So 5 squared is 25. 7 squared is 49. 25 plus 49 is 74. So we can say that, this is E, so we can say that EB is equal to the square root of 74. And now we've calculated this length here, we can now calculate this length, because we know 2 of the other side lengths. So we know the hypotenuse of this triangle, and we know one of the shorter lengths. So to work out this length, we're just going to do 15 squared. We're going to use Pythagoras again, 15 squared. But this time, instead of adding, we're going to subtract because we've already got the hypotenuse. So 15 squared minus this red length squared. So that red length is root 74. So root 74 squared. And that's going to give us BC squared. BC squared. So let's work out what that is. So 15 squared is 225. Root 74 squared, well, that's just 74. So what does that give us? 225 minus 74. That gives us 151. Therefore, BC is the square root of 151. Well, we just leave it as the square root of 151 for now. So we have found out that this length here is the square root of 151. And now we've got all 3 side lengths. We can calculate the volume. So the volume is we're just going to multiply all of those 3 lengths together. So it's going to be 5 multiplied by 7 multiplied by the square root of 151. And when I put that into a calculator, I get 430.09. Now it says to give your answer correct to 3 significant figures. So our answer is going to be 430. Now technically this is only 2 significant figures, so we can just include the decimal point there, just to show that 0 is definitely significant. Question 13. There are 14 boys and 12 girls in a class. Work out the total number of ways that 1 boy and 1 girl can be chosen from the class. Well, if you think about this, there are 14 boys and each boy can choose 12 girls. So work out the total possible number of combinations. Well, we can just do 14 times 12. It's as simple as that. 14 times 12, that will give us the total number of combinations, and that gives us 168. So there are 168 ways that 1 boy and 1 girl can be chosen. Question 14. Write all of this as a single fraction in its simplest form. You must show your working. Well, let's just ignore the 4 for now and just focus on what we've got in the brackets here. So I can see that we're dividing by a fraction. Now, whenever we're dividing by a fraction, that's the same as multiplying by the reciprocal of that fraction. So we've got x plus 3. We've got x plus 3. And instead of dividing, I'm going to multiply it by this fraction, but flipped upside down. So on the top, we've got x minus 2. And in the denominator, we've got x squared plus 5x plus 6. And I think that just makes it a bit easier for us. Let's just put over 1 here, just so we've got two fractions. Now, whenever you're asked to simplify fractions that involve quadratics, you should immediately go to factorising. Think about factorising. So down here in our denominator, we can factorise this quadratic expression. So two numbers that multiply together to get 6 and add together to get 5, well, those two numbers are 2 and 3. So we can factorise this. So let's just rewrite all of it. So we've got x plus 3 multiplied by x minus 2, all of that over, and then this can be factored to x plus 2, x plus 3. And let's just put that over 1 again. And now, hopefully you can see that the x plus 3's will cancel out with each other. We've got an x plus 3 in the numerator, we've got an x plus 3 in the denominator. So all we are left with is 1 times x minus 2, which is just x minus 2, and 1 times x plus 2, which is just x plus 2. So everything in this bracket here gets simplified to x minus 2 over x plus 2, and we're going to do 4, subtract all of this now. So remember, whenever we are adding or subtracting fractions, the denominators need to be the same. So that's essentially 4 over 1. So I need to make both denominators x plus 2. So if I multiply this whole fraction by x plus 2 over x plus 2, that gives me 4 x plus 2 over x plus 2. And then I'm going to subtract x minus 2 over x plus 2. So what does this give us? Well, we can expand the brackets first. So 4 times x is 4x, and 4 times 2 is 8. So that's going to be 4x plus 8. And all of that is over x plus 2. And then we're going to subtract x minus 2 over x plus 2. And now we've got the same denominators, we can just subtract the fractions. So if we, well, subtract the numerators, I should say. So 4x plus 8 minus x, that's going to be 3x. And then 8 subtract negative 2. So this bit, a lot of people make a mistake with. We're not taking away 2, we're taking away negative 2. So essentially, we are adding 2. So it's going to be 8 plus 2, which is 10. So it's 3x plus 10 in our numerator. And in our denominator, well, we've just got x plus 2. So that is our answer. 3x plus 10. 3x plus 10 in our numerator. And x plus 2 in our denominator. Question 15. A virus on a computer is causing errors. An antivirus program is run to remove these errors. An estimate for the number of errors at the end of t hours is 10 to the power 6 multiplied by t to the power negative, 2 to the power negative t. Okay, work out an estimate for the number of errors on the computer at the end of 8 hours. So in this instance, t hours, so t is going to be 8. So we can just substitute 8 into this expression. So it's going to be 10 to the power 6 multiplied by 2 to the power negative t. That's negative 8. And again, we can use a calculator for this. So let's just type it in just to make things simple. So 10 to the power 6 multiplied by 2 to the power negative 8, which gives us 3,906.25. So this is only an estimate. So we can round this. Let's round it down to 3,906. You can't have, I don't think you can have a quarter of a virus. I might be wrong, but we'll just round it to the nearest virus. Okay, question B. Explain whether the number of errors on this computer ever reaches 0. So it's basically saying that can the formula that we've got, so 10 to the power 6 times 2 to the power negative t, can that ever equal, or can that ever reach 0? Now, the reason why it can't reach 0 is to do with this bit here. Okay, 2 to the power negative t. Because if t is the number of hours, you can only ever have positive t values. So, for example, 2 to the power negative 1, well, that's going to be a half. 2 to the power negative 2, so after 2 hours, that's going to be a quarter. 2 to the power negative 3, after 3 hours, that's going to be an eighth. So notice how this part of our formula is never equal to 0. So if we're multiplying that by this, we're still never going to get 0. So we could say, for our explanation, we can say that 2 to the power negative t will never equal 0. Never equal 0. Therefore, when we multiply that, by 10 to the power 6, we will always get a positive answer. We will always get a positive answer. The graph of y equals f of x is transformed to give the graph of y equals negative f of x plus 3. The point A on the graph of y equals f of x is mapped to the point P on the graph of y equals negative f of x plus 3. The coordinates of point A are 9, 1. Find the coordinates of point P. So we've got point A being mapped onto point P. So we know that point A has the coordinates 9, 1. And now let's look at how the graph has been transformed. So we can see that inside the brackets we've got x plus 3, and that means that our graph has been translated or shifted 3 units to the left. So let's just write that down. And we can also see that the graph has been transformed from f of x to negative f of our function. So that just means that it's been reflected over the x-axis. So if we take our set of coordinates and first of all translate these coordinates 3 units left. So the x coordinate, that's going to go from 9 to 6. And the y coordinate, that's not going to change because we're not moving it up or down. So it's still going to be 6, 1. And now if we reflect that over the x-axis, so what are our coordinates going to be now? So we're still going to be 6 along because the x coordinate's not going to change when we reflect it over the x-axis, but the y coordinate will. So that will go from 1 to negative 1. So the coordinates of point P, let's just write it down up here, are going to be 6, negative 1. Question 17. The diagram shows a solid cone. The diameter of the base of the cone is 24x centimeters. The height of the cone is 16x centimeters. And we're told that the curved surface area of the cone is 2,160 pi centimeters squared. The volume of the cone is v pi centimeters squared, so we don't really know what that is, but we are told that v is an integer. Find the value of v. We need to find sort of what the volume of the cone is. So, and we are given the formulae here, so that's quite helpful. So first of all, let's calculate. We need to know what the radius is. So to work out the volume of the cone, you can see here that in our formula is the radius. So we need to work out what the radius is. So let's do that. And to do that, we're going to use the fact that we know what the curved surface area of the cone is. So the curved surface area is going to be pi times the radius times the length. And we know that when we calculate that, it's going to be 2,160 pi, and that is centimeters squared. So first of all, what is the radius? Well, the radius, if the diameter is 24x, the radius is just going to be half of that. So the radius is going to be 12x. So it's going to be, oh sorry, we've still got pi. So it's going to be pi times 12x multiplied by our length. Now, at the moment, we're not told explicitly what our length is. So the length is the slant length. So it's this length here. But using Pythagoras, we can calculate it. Because if this is 12x, and we know that the height is 16x, we can calculate the slant length using Pythagoras. So let's do that down here. So it's going to be 12x squared plus 16x squared plus 16x squared, and then we're going to take the square root of that. So what is 12x squared? Well, that's going to be 144x squared. 16x squared is going to be, what's 16 squared? 16 squared is 256, so it's going to be 256x squared. So let's add those together. We get 400. 400x squared. So now we just need to take the square root of that. So the square root of 400x squared, well, the square root of 400 is 20, and the square root of x squared is just x. It's going to be 20x. So we know that the slant length is 20x. That's pi times 12x times 20x, and that equals 2160 pi. So let's calculate what this is on the left hand side. So 12 times 20 is 240. So it's going to be 240. X times x is x squared. And then we've got the pi as well. So we can just say 240 pi x squared. And that equals 2160 pi. Now we've got a pi on both sides. So we can just get rid of those pi's. Okay, we can just get rid of those pi's. And we can, so now we've got, let's just do each step. We've got 250 x squared equals 2160. So now to get x squared on its own, if we divide both sides by 240, we're going to have x squared equals 2160 divided by 249. So that's kind of, when you get an answer like 9, which is a square number, you should be quite happy that you're probably on the right track. So if x squared equals 9, then x is either plus or minus 3, but in this case it's just going to be plus 3 because we can't have negative lengths. So we know that x equals 3. Let me just box that. X equals 3. So that is what x is. So now we can work out the radius. Because if we know that x is 3, well, we know the radius is 12x. So the radius is going to be 12 times 3, which is 36. So it's 36, and that is in centimeters? Yes, 36 centimeters. So we know that the radius is 36 centimeters. We still need to calculate the volume. So if we look at the formula for the volume of a cone, so the volume is going to be 1/3 times pi times our radius squared. Well, our radius is 36, so 36 squared, and then multiplied that by our height, and our height is 16x, and we know that x is 3, so let's just write this down here. So the height is going to be 16 times 3, which is 48 centimeters. So multiply that by 48, and now we can just use our calculator. So it's going to be pi, 1/3 of pi multiplied by 36 squared multiplied by 48, and we get 20,736 pi, and that is in centimeters cubed. So that is our volume. Now, if we look at the question, the volume of the cone is V pi centimeters cubed. So V is just this number here. Okay, so if we just replace V with this, that gives us our volume. So find the value of V. Well, V is 20,736. Question 18. Thelma spins a biased coin twice. The probability that it will come down heads both times is 0.09. Calculate the probability that it will come down tails both times. So we've got a biased coin. So we've got heads and tails, and she spins it twice. So let's do 2 events. So heads, tails, tails. The probability that it will come down heads both times is 0.09. So heads times heads is going to be 0.09. So we can work out the probability of it landing on a heads once is just take the square root of 0.09, which is 0.3. Remember, these have to be the same. Although it's biased, the coin doesn't change each spin. So if it's 0.3 on the first spin and 0.3 on the second spin, or 0.3 times 0.3 is 0.09. So if we know that it's 0.3 for heads, then what is the probability for tails? Well, that has to be 0.7 because they have to add up to 1. So now we know the probability is 0.7 for tails. Calculate the probability that it will come down tails on both times. Well, that's just going to be 0.7 multiplied by 0.7, which gives us 0.49. Question 19. Write 0.000423 in standard form. Now, whenever we're writing something in standard form, the base number, the first number, has to be between 1 and 10. So if we look at the digits we've got here, our base number is going to be 4.23. And we're going to multiply that by 10. And then we just need to think about the power. So we're getting smaller. So it's going to be a negative power. So let's write this out a bit bigger. It's quite hard to see. So we've got 0.000423. So we're saying that it starts at 4.23. So we're going to divide by 10. So how many times? 1, 2, 3, 4 until we get here. So it's minus 4. So it's 4.23 times 10 to the power minus 4. And now part B, write 4.5 times 10 to the power 4 as an ordinary number. So we've got 4.5. And we're multiplying that by 10 4 times. So if we multiply it by 10 once, that gives us 45. If we multiply it by 10 twice, that gives us 450. 3 times will be 4,500. 4 times will be 45,000. So our answer is 45,000. Question 20. Mark has made a clay model. He will now make a clay statue that is mathematically similar to the clay model. The model has a base area of 6 centimeters squared, and the statue will have a base area of 253.5 centimeters squared. Mark used 2 kilograms of clay to make the model, and clay is sold in 10 kilogram bags. Mark has to buy all the clay he needs to make the statue. How many bags of clay will Mark need to buy? So first thing I can see is that we're told the model has a base area of 6 centimeters squared, and the statue will have a base area of 253.5 centimeters squared. So we can work out the scale factor, and that is going to be the area scale factor. So the area scale factor, so how many times bigger is the statue's area compared to the model's area? Well, if we just divide 253.5 by 6, that gives us 42.25. So we know that the statue, the area of the statue is 42.25 times bigger than the model. Now, because we are making a model, we need to think about the volume of the statue. So to calculate the volume scale factor, let's first of all calculate the length scale factor. So the length scale factor, well, we're just going to square root this. So it's going to be the square root of 42.25, which gives us 6.5. 6.5. So the model has, so each dimension of the statue is 6.5 times bigger than the model. And now the volume scale factor, we can just do 6.5 cubed. 6.5 cubed. And that gives us 274.625. So the volume of the statue is this much times bigger than the volume of the model. So if Mark used 2 kilograms of clay to make the model, then how many kilograms of clay would he need to make the statue? Well, we're just going to do 2 kilograms multiplied by our scale factor, our volume scale factor, which is 274.625. So if we multiply those two together, we get 549.25 kilograms. That is how many kilograms he needs to make the statue. Now, clay is sold in 10 kilogram bags. So to work out how many bags of it he needs, we can just divide this by 10. So 549.25 divided by 10. That's quite easy to do. That's going to be 54.925 bags. But you can't really buy 0.925 of a bag, so let's just round this up to 55 bags. So it looks like Mark needs 55 bags to make his statue. Question 21. Show that the equation, or this equation here, can be rearranged to give this equation. So I think the first thing I'm going to do is just get rid of this 3. So I've got the 3 on the left. So we're going to have 3x squared minus x cubed, and that's going to equal -3. And now if I divide everything by x squared, so let's just write this on here. So I divide everything by x squared. What am I left with? Well, 3x squared divided by x squared is just 3. And then it's going to be minus x, because x cubed divided by x squared is just x. And that equals -3 over x squared. And it looks like we've got something similar, but we've got plus 3 over x squared instead of minus 3 over x squared. So if I put this on the other side, it will turn into a plus. So if I add this to both sides, then I'm going to be left with 3 plus 3 over x squared. And if I put this negative x on this side, well, that's going to become positive. So it's going to be equal x. And that's exactly what we've got here. It's just round the other way. So I can just put these on the other side of the equation. So that's exactly the same as x equals 3 plus 3 over x squared. And we're done. Okay, part B. Using this iterative formula with x sub 0 being 3.2, which effectively means that's the first input that we're going to put into our formula. Find the values of x sub 1, x sub 2, and x sub 3. Now, with a calculator, there's a really quick way you can test all of these numbers. First thing to do is, because 3.2 is our first guess, we can just type 3.2 into our calculator and then press equals. And that saves 3.2 on the calculator as your first input. And now we can just type in the formula. So 3 plus 3 over 3.2 squared. But because 3.2 is saved as our answer, we can just type in answer, the answer button, squared. And that will give us our answer. So let's type that in. So 3 plus 3 over answer squared. And we get, I'm just going to round these to 4 decimal places because it doesn't say in the question how accurate to be. So 3.2930. 2930. Now for x sub 2, all we need to do with our calculator is press equals, because it's saved, because this effectively, this is our new answer that we're going to input into our formula. So all we need to press is equals, and it gives us our second answer, which is 3.2767. And then exactly the same for x sub 3, press equals, and we get 3.2794. So those are our 3 answers. Now if we look at question C, it says explain what the values of x sub 1, x sub 2 and x sub 3 represent. So what are these numbers that we've got? Well, these are just estimates to our equation, our original equation that we had up here. So they're getting more accurate as we go down. So these are increasingly more accurate estimates to the solution of our original equation. Okay, now let's go on to question 22. And now this is the last question of the paper, question 22. And notice down here, this is worth 6 marks. So this might take me quite a while to do. So here are the first 5 terms of an arithmetic sequence. Prove that the difference between the squares of any two terms of the sequence is always a multiple of 24. Now this is quite long-winded, quite wordy. But first of all, let's just work out what the nth term of this sequence is. So what is the nth term? Well, it's an arithmetic sequence, so it should go up by the same amount each time. And indeed it does. I can see that it goes up by 6 each time. It's going to be 6n. and it's 1 more than our 6 times table, so it's going to be 6n plus 1. And for this, I think I'll just get my highlighter out to highlight different parts of the question that are important. So, any two terms. So, how can we express any two terms? Well, one term we could say as being 6n plus 1. That would be some term. Like, for example, when n equals 20, this is going to be 6 times 20 plus 1, which is 121. So that's one term. Another term, or we could just change the n to an m. So it could be 6m plus 1. So that'd be another term. So as long as n and m are different, then these are two different terms. Now let's go back to our question. So prove that the difference between the squares of any two terms. So the squares of any two terms. So we need to square these numbers. So let's do that. So we're going to square both of these terms, these numbers. These effectively are just numbers, because when we put our term number in here, we just get a number. So let's FOIL this out. So I'll do it fully. So we've got 6n plus 1 multiplied by 6n plus 1. So 6n times 6n, that's going to be 36n squared. 6n times 1, well, that's just going to be 6n. And then we've got another 6n times 1, so that's another 6n. And then plus 1 times 1, which is 1. And we can simplify that. So this is the same as 36n squared. 6n plus 6n is 12n. So plus 12n plus 1. Now, if we do that, the same thing for this one here. So 6m plus 1 times 6m plus 1. Well, we don't need to kind of do all of this because it's exactly the same, but I've just replaced the n's with the m's. So we're going to have the same thing. It's going to be 36m squared plus 12m plus 1. Right, okay, let's go back to our question. So prove that the difference between the squares of any two terms. So we need to work out the difference between these two numbers. So the difference between the squares. So it's just going to be 1 subtract the other. So we've got 30. Oh, let's go back to my pen tool. I'm forgetting that. So we've got 36m squared plus 12m plus 1. And we're going to take away this. So I'm doing this one in red, subtract this one in black. So I'm going to take away 36n squared. I'm going to take away 12n. I'm going to take away 1. And what I think I'll do is just group them together so we've got all the same numbers together. So we've got 36m squared minus 36n squared plus 12m minus 12n. And then we've got 1 minus 1. Well, those two will just cancel out with each other. So this is what we're left with. So we need to prove that this is a multiple of 24. Now the first thing I can see is that we can straight away factor out a 12. All of these terms are divisible by 12, so let's factor out a 12. So if we factor out a 12, we're left with 3m squared minus 3n squared plus m minus n. So now we need to prove that this is a multiple of 12. And remember, n and m can be any values. So let's do some scenarios. Let's do some scenarios where m and n are different combinations of even and odd numbers. So let's say that m is odd. So what happens basically if m is odd and n is odd? Okay, so here we know that this is divisible by 12. We need to know that it's divisible by 24. So if we can, what we can do is, if we can discover or find out that this is even, I'll just write it there. If this is even, then if we're going to multiply by 12, then this whole thing will be divisible by 24. Because 12 times any even number is going to be a multiple of 24. So for example, 12 times 2 is 24. That's a multiple of 24. 12 times the next even number, which is 4, which is 48. That's divisible by 24. So as long as we can prove that this expression is even, then we know that this whole expression is divisible by 24. So let's first work out what this first term is if m and n are odd. So we're going to have an odd squared, which is an odd, times that by 3, well, that's still going to be odd. So this here is going to be an odd number. I'm going to take away this. Well, this is also going to be an odd. It's exactly the same because they're both odd. So we're going to take away an odd number. And then we're going to add an odd number. And then we're going to take away an odd number. So is that going to be even or odd? Well, an odd take away an odd is going to be even. And then if we add an odd, that's going to go back to odd. And if we take away an odd, that's going to go back to even. So that overall will be even. So when we're multiplying 12 by an even number, we will get a multiple of 24. Now let's pick the scenario where both of them are even. So first let's think about this first term. So we've got an even squared, which is an even. And then we multiply that by an odd number. We've still got an even number. So the first term is going to be even. I'm going to take away this, which again, that's going to be even. And now we're going to add on an even number. And then we're going to subtract an even number. So an even minus an even plus an even minus an even, well, that's still going to be even. So that is also going to be even. And now the last scenario is if they're different. So if m is odd and n is even, or vice versa. It doesn't matter which way round they are. So let's just say m is even and n is odd. We only need to check one scenario. So first of all, if m is even, well, we know if m is even, this first part is going to be even. This second part, well, if n is odd, this second part is going to be odd. It's an odd squared multiplied by an odd. So it's going to be an even minus an odd. And then plus m, which is even, minus n, which is odd. Okay, and if we've done this correctly, that should also give us an even number. So an even minus an odd is going to be an odd. If we add an even, that's still going to be odd. And then when we take away an odd, that's going to go back to an even. So we are correct, they are all even. So just to conclude with a final statement, we can say that inside our brackets, we do have an even number. So whenever we multiply an even number by 12, this will always be a multiple of 24. So I'll just write that down. Now I know that all of this writing here is a bit excessive, but as long as you can prove that this expression here is even, then you should get the marks. Okay, well that's the end of the higher series of papers. So I hope you enjoyed that, and I hope it was helpful, and it just helped you with understanding my thought process when I went through each question. I'm going to do another series of videos with GCSE walkthroughs, and I'm going to look at foundation papers. So I'm going to do the paper 1 non-calculator, and then I'm going to again do two more calculator papers on the foundation tier. Okay, thank you very much for watching. Hopefully I'll see you soon. Take care.